Hello, this is the Dream Team. Okay, let's talk about the problem. So reviews are very stale, which means that a review from a year ago can't really hold the amount of water that a review holds from now. So being able to merge that conflict is very difficult and also dissolution. Um, Reviews are also varied, so you can have reviews in different languages, and also the reviews can talk about very different things. And sometimes reviews don't have titles, and sometimes reviews are 10 characters, and that's not really meaningful for users trying to buy a hotel. And they're also barely complete. So by that I mean basically it talks about one exact thing, and it doesn't talk about the entire like hotel experience sometimes, right? Because reviewers stick with one thing. So our EDA showed us the same, right? So the reviews on average are 50 characters long, they're undercased, and 90% have no titles. And even on top of that, the least amount of talked topics are pets, Wi-Fi, the check-in experience, which is kind of interesting. So we wanted to make a solution that focuses on those specific gaps, and we want to make it per property, and it dynamically asks users about said gaps. But we went a step further, where we wanted to normalize the review shape, so that everyone can see that review is meaningful, where it asks a decent amount, gives a decent amount of information, so that users can be informed of what they buy. Our solution is simple: you input your review, and then we extract we extract the segments via an LLM, and then we also run a local TF-IDF model, and a logistic regression model to extract the facets as well. So those facets are then ranked with logistic regression through TF-IDF, and then all this is passed into the readiness gate. So the readiness gate decides whether your review is too thin or too thin. If it's too vague, the LLM asks follow-ups to get more information, and then you go through the algo again. After that's done, you get a ranking algorithm, which is our pairwise logistic regression model. It's a learned linear ranker, and it outputs the top missing facet compared against the corpus, which is the data set. So you can be talking about, the breakfast is great, all this is great, but you didn't talk about the parking. So our model will then ask about the parking. As the LLM will get that information, it'll ask about the parking. The user will hopefully answer it, and the LM then appends the entire review session into a single final review that the user can approve or disapprove. And if the user approves, great. If the user disapproves, you can chat with the LM to make the review more your shape, and then it approves again. And we persist that into the model card. So this is how we go about it, right? This is our site. We have auth, so you can log in, blah, blah. Let's demo this really quick. So let's go to Ocala, right? Let's write a review. Let's say that our experience in Ocala was absolutely piss poor, right? So we go here. All right, now let's do this. And let's start with vague, because most people start vague. It was terrible. Down. Okay, so it tells us this. So let's say the room condition was bad, nothing was made, and it had stains all over. The parking was not there. Yeah. So this, yeah, and there we go. So now it has everything. And let's say it was terrible, the room condition was bad, and nothing was made, had stains all over. Also, and this question right here was the targeted follow-up question. We wanted to make it natural. Okay. So then we just submit the review, and it saves the review, it recomputes the score, and we can see that there's 2 traveler reviews. Now we can go back, and if we go to here, you see that there we go. Okay, so what stands out from this is the actual cost. We're only using 1 to 2 LLM passes, which cost around less than 1 cent, right? And we also wanted to make it fast, so that's why we added a deterministic rule ranker along with a logistic regression rule ranker. This is very scalable, because if one review costs less than 1 cent, then the actual cost per review is going to be the cost at scale is going to be very nice. And it's better than an LLM judging at each step, because number one, LLMs are not deterministic, and number two, an LLM pass costs money, and we're using GPT 5.4 Nano, which is very cheap and very fast. So the thing that we wanted to basically produce is something that can be scaled to millions of users while also holding the same amount of truth. And per property. So we ingest all the property reviews and we go about it that way. So that's why I think our solution is very interesting